My thanks to Rohini for organizing this special session to honor ECG Sudarshan and inviting me to speak. Mine will be a personal account, and there will be some overlap with the previous speakers. I had the privilege of a close personal relationship with Sudarshan for about 30 years, from 1961 to about 1989. Recently, I found this is exactly the period, the creation of the Berlin Wall and its destruction. I got to know Sudarshan when he was young. We were 8 years apart. He was my PhD guide, and our collaboration led to about 55 papers, many of them with Simon. The collaboration, our work together was in the areas of particle physics, classical and quantum mechanics, classical and quantum optics, all dominated by the ideas of symmetry and group action on physical systems. In 2006, a conference was held to celebrate ECG's 75th birthday. It covered his 7 major areas of work. 4 of them have been discussed by the previous speakers. The other 3 were tachyons, the connection between spin and statistics, and symmetry in general. ECG had a very wide range of interests and contributions. There were 3 physicists who have had major influences on him as a young man: Robert Marshak, P.A.M. Dirac, and Julian Schwinger. Marshak was a friend of Homi Bhabha and met ECG when he visited TIFR in 1953. He was so impressed that he persuaded George to come to Rochester to work for a PhD. George went there in 1955, and the joint work with Marshak on the V-A theory of weak interactions done in 56-57 was his thesis work. I want the physicists to remember, to know that some of his fellow students known very well in the field of physics were Tullio Reggi and Susumu Okubo. Dirac had been a teacher of Bhabha at Cambridge in the 1930s. He visited TIFR in 1954 and gave a series of lectures on quantum mechanics. The notes of those lectures were written by ECG and K.K. Gupta, a student of Bhabha. Those notes, the well-known yellow volumes, used to be available until recently. They may still be available in some form. Dirac and ECG became lifelong friends. ECG's admiration for Dirac was total, and so was mine. This is one of the reasons that brought ECG and me close together. A high point in my life was being present at a dinner at the ECG's home for Paul and Margit Dirac in April 1973 in Austin, Texas. I spent the evening watching their favorite TV program with just the 2 of them in the downstairs TV room. As for Schwinger, ECG went to Harvard after PhD and worked under his guidance for 2 years, 1957 to 59. Then he came back to Rochester as a faculty member. In many conversations with me, ECG expressed very great regard for Schwinger. Now let me see if I do it right. Yeah. Of all of ECG's work, 2 are generally regarded as being of the Nobel class: the V-A theory of the weak interactions and the diagonal representation in quantum optics. Debajyoti Chaudhary and Rajaya Simon have spoken about these 2 in great detail. Shiraz also, in his inimitable style, has told you about it. As for V-A, ECG always felt Marshak had not promoted it sufficiently strongly in the physics community. Recall that Marshak was a contemporary and a very good friend of both Richard Feynman and Julian Schwinger. In 1991, in an after-dinner talk celebrating ECG's 60th birthday, Marshak spoke of the pain and joy of a, where is it? The pain and joy of a major scientific discovery. In very eloquent language and with great humility, Marshak asked for ECG's forgiveness for his three cardinal blunders, as he called them. Not giving ECG a chance to present their results at the 7th Rochester Conference in April 57, submitting their paper to a conference but not simultaneously to a regular journal, and sending their short paper to the physical review only after the Feynman-Gell-Mann paper had appeared. The three physics Nobel Prize winners of 1979, Glashow, Salam, and Weinberg, have all spoken highly appreciative of ECG and Marshak's work, how crucial it was for their own work, and expressing regret that it was not adequately recognized. You can read their comments in the special section of Current Science put together by Rohini and the rest of us in January 1929 and also in the Resonance issue of February this year. I want only to quote from Salam what he said when he gave Sudarshan the 1985 Physics Prize from TWAS. Here is what Salam said. All this was based on the work done by Sudarshan and Marshak. Instead of their being recognized, others were for a long time credited with the same theory, which was done after this work, that is Sudarshan Marshak work. We know it. All the people in the subject knew it. But somehow there was a conspiracy of silence on the subject which harmed him and recognition of his work. With regard to the work in quantum optics, I should mention that ECG was very close to and collaborated a great deal with both Emil Wolf and Leonard Mandel. Wolf was the leading exponent of classical optics in his time, especially of the theory of partial coherence, and in many ways, Mandel created the field of quantum optics and brought out the significance of ECG's work most effectively. Simon has described this whole episode so beautifully. Let me mention two pieces of ECG's work which should be better known within the physics community. In 1957, ECG with Okubo and Marshak obtained for the first time the results of broken symmetry in particle physics. This was for the masses and magnetic moments of the so-called sigma particles, and it seems that they did this work because they had a discussion with Salam, who was visiting Rochester, and Salam suggested to them that they look into this problem. So this set of results for the sigma particles is an exploration of the consequences of violation of isospin symmetry by the electromagnetic interactions. Most people, even in particle physics, do not know this was the very first time such results were ever derived in the field, and it was a precursor to the famous Okubo sum rule for masses in the SU3 theory of Gell-Mann. The second is a 1963 result of Sudarshan ECG with two of his students, Douglas Curry and Tom Jordan, in the area of classical relativistic Hamiltonian particle dynamics. It's a long phrase, big name, words. This work was done, I think, in 1962, completed in 1962. It appeared in the Reviews of Modern Physics in 1963. It goes back to some of Dirac's work of 1949. Dirac had done that work and published it in the volume celebrating Einstein's 70th birthday. I tell you all these things because I'm an old person now, and young people otherwise would not know, come to know these things. They showed, Sudarshan, Curry and Jordan showed that special relativity by itself does not ensure the existence of world lines for particles, classical particles, in an objective sense. Something additional has to be demanded if you wish to have well-defined world lines. And they then showed if you add those demands to special relativity, no interactions are allowed. So this is a famous no interaction theorem in this context, and it was studied quite extensively in the 1980s. I said at the start that this would be a personal account, and Rohini gave me permission to take that attitude. On many occasions, working together, we found results which truly delighted us. I will mention just two of them. Around 1949 and 1950, Dirac presented a beautiful extension of traditional classical mechanics called constrained Hamiltonian dynamics. I think ECG learned about it directly from Dirac when Dirac was at TIFR in 1954, and then in due course, I also learned about it. In Dirac's paper, he presented an extension of the familiar Poisson bracket of classical mechanics. Every graduate student knows that. It is called now the Dirac bracket. And in the appendix to his paper, 1950, the Canadian Journal of Mathematics, he proved the Jacobi identity for his new bracket. His proof was laborious and completely unenlightening. In fact, when he lectured about this in Yeshiva University in 1964, Dirac said, I have been unable to find a simple proof of the Jacobi identity. So after many attempts, one summer evening in 1965, George and I decided we should work through Dirac's proof in full detail. So around 5 p.m. one evening, we sat down on the carpet in ECG's living room. We were visiting Syracuse that summer, and we had a whole pile of large computer sheets to work on. In those days, we could get these computer sheets to do long calculations. So we started at 5 in the evening, and we went at it continuously for 6 hours. Till at 11 p.m., we had reconstructed Dirac's proof, emotional, in full detail. Then after a few weeks, we did find an elegant and simple proof which had missed Dirac. Then again, in the mid-1960s, we became interested in the unitary representations of non-compact Lie groups. I don't remember why, but we became interested, both of us, specifically the Lorentz group of special relativity. Once again, the story goes back to Dirac, to work he first did in 1945. And then Harish Chandra went as a student of Dirac from IISc in Bangalore to Cambridge to work with Dirac for the PhD. And in 1947, he wrote his thesis, and he continued Dirac's work. And this is what we got interested in the mid-1960s, late 1960s. It turned out that the equations we were looking at from the Lie algebra relations of the Lorentz group, they seem to suggest that you could have a Hermitian operator for the physicists, a Hermitian operator whose eigenvalues were continuous, and of course they were real, but they could be shifted by complex amounts, plus or minus I, which was very, very puzzling. And then along with Jacob Kurian, another student of ECG, we were able to solve this puzzle and understand exactly what was going on. In both instances, which I have described, I should say that we studied these problems only because they seemed interesting and challenging to us, without regard at that time of impact or immediate application anywhere. This was possible in those days. Back to ECG now. Throughout his entire professional career, he was in the US, but he always maintained very close links with physicists and institutions in India. Looking back over the last 60 years, I might mention three important names, people with whom he was very close as far as I remember. S.N. Biswas, who is no more, T. Pradhan, who is still with us at Bhubaneswar, and P.M. Matthews in Madras, who is still there, out of many. Matthews is the same one who was a co-author in the work that in the 1961 paper, which Subhash reminded us about. Over the 1960s, he made many extended visits to India, largely to Delhi University and the University of Madras, and to the Institute of Mathematical Sciences. Then in the early 1970s, guided and goaded by Satish Dhawan and D.S. Kothari, he set up a Center for Theoretical Studies at the Indian Institute of Science in Bangalore. In later years, this gave birth to the Center for Ecological Sciences, the Center for Atmospheric Sciences, the Developmental Biology and Genetics Laboratory, and finally, the present Center for High Energy Physics, all within the institute. In 1984, he became director of the Institute of Mathematical Sciences in Chennai, leading to a great expansion of its range of activities, facilities, and support. Among important awards, I should mention the Dirac Medal from Trieste and the Majorana Prize instituted in the centenary year of Majorana's birth, and within the country, the Padma Bhushan and Padma Vibhushan. ECG was a gifted and eloquent speaker with a very ready wit and a great sense of humor. He was often quoted with great ease from Sanskrit. He once told me this story, which I am always tempted to repeat. He was once invited to a very high society dinner in Bangalore, and he was seated at one corner of a very long rectangular dining table, one corner. Exactly at the diagonally opposite corner were two other guests, A and B. And pointing at ECG, A asks B, "Who is that gentleman sitting far away from us?" And ECG told me he heard B's reply, "Don't you know? That is the great Indian physicist S. Chandrasekhar from the University of Chicago, who won the Nobel Prize for his work on liquid crystals." This to lighten the mood. I mentioned two of his works of Nobel class, and you have heard in detail about them earlier. The fact that he was not recognized at that level distressed him deeply. And in later years, he expressed his feelings publicly quite often. He was nominated 8 or 9 times for the Nobel Prize. For comparison, I should tell this audience, the great physicist Arnold Sommerfeld was nominated for the Nobel Prize 84 times and never made it. 4 of his students won the Nobel Prize, but not poor Sommerfeld. I often think, when I remind myself of this, of some profound words of Max Planck, which are actually relevant for all of us lesser mortals. So let me conclude with this passage from Planck. "For it is work which is the favorable wind that makes the ship of human life sail the high seas, and as for the evaluation of the worth of this work, there is an infallible time-honored measure, a phrase which pronounces the final authoritative judgment for all times. By their fruits ye shall know them. Thank you again, Rohini, for this chance to speak about my teacher.